bore, the diameter is 35 millimetres.
Bore diameter?
Yeah.
55?
35.
35.
Yes.
Bore diameter.
Okay.
This is contact length. Right.
Okay. So we have that now. We should have.
Save these drawings so we can refer.
We can print them if we can print them.
Or you can save the PDF.
Okay. Can we have that here?
Yeah.
Okay. Is that helps?
Yeah, and we can download the CAD model, but I think it takes a while.
So okay, we have the designation, so we can do that. Just it hasn't come out the figures up there. So desktop, what we'll do is we'll say, can you just give me the designation of the bearing again?
YEL 207
207.
2L dash 2L.
Yeah, we'll know what that means. Okay, so we have that. Right. Essentially, what we have to do next is we now know some of the dimensions of the shaft. Okay.
Okay. So bore diameter 35. Yeah.
Mhm.
Does that mean that's the maximum size?
That's the bore diameter is the diameter of the shaft that goes through the bearing.
Yeah. If we need it bigger, then we need to reselect the bearing.
We'd have to choose a completely different bearing, yes. We need to step down for the pulley.
Yes. What was the diameter?
There is no diameters for the pulleys,
Please?
if I understand it correctly.
It's up to us to.
It's essentially drilled,
Oh,
it's
yeah.
machined, whatever is needed. A pilot hole's given and then from that expanded. If we, can we just do, we started this previously, but if we take a new page, can we just draw, we'll essentially copy this just simple drawing of the shaft with the known dimensions, because that's what we'll have to start from when we can actually start thinking about how strong this shaft is going to be.
Right, so we want to sketch the
Yeah.
shaft.
Yeah, because we know a few of the pieces of geometry.
Yeah. What was our layout again? Do you have it?
So you have the motor at the very left end,
Right.
and then we have the bearing, which will be the
So
ball bearing
15
we just selected.
So yeah, the bearing A, which is
Diameter of 35.
35.
Okay.
Then we should have a step up. 550 length.
To the pulley. Now that should be located against something, I suspect. Whether
Right.
that's
Do
just
we
the
have a
interference feed that could fit against the shoulder.
So we wouldn't have any step.
We-
Okay.
We should have, sorry,
We
just a
could
shoulder,
have,
just
okay,
a step
just
up.
a
but
step up like that.
yeah, something to locate against. We could just have it as just a ring as
I
opposed
just
to
don't have space to draw this.
That's okay.
So this is the pulley.
We may choose to do it the other way.
Yeah, the step could be
The other
going
way.
down.
I
yeah.
suspect it makes more sense to do the other way. It doesn't matter for the minute. No. We just need the last one for the bearing, which we chose at 25. So
Well,
the problem is
this
that's a
would be this
massive
lot
change,
smaller.
which is why I'd
Okay.
rather the
Shall I
shoulder
just-
went the other way.
We do this because
Essentially-
this does not make
yeah.
sense, I think.
We want.
Yeah, let me just put across there.
Yeah.
Okay, so we start with motor.
Just for the benefit of the camera, the problem there was the step going from left to right at the pulley, at the pump pulley, was outwards, basically greater diameter. Essentially, the pulley would butt up against the shoulder to its right as we look at the drawing, which meant there was a massive diameter change when it got to where the bearing at that end was going to be mounted. So now we're going to have the step the other direction coming inwards. So essentially we only have one change in diameter the whole length of the,
Yes.
as it currently looks.
Yes.
So we only have two changes in diameter
Yeah. So with a thicker
at the moment.
section in the motor.
Essentially we're going to have a slightly smaller diameter at the motor pulley as well. A shoulder for that.
You mean this one?
At the motor pulley, so the very left hand end.
We
We're going
need-
to step somewhere there.
Up or
down, because it won't go on otherwise. The bearing has to go all the way to point A, and then the pulley goes on afterwards.
yeah, right.
So it needs to be slightly smaller. I'd make that step change as small as we possibly can,
Okay.
just enough to
Did we
provide.
have a diameter for the motor
No, we have no diameters as yet for any of the
pulley?
In terms of the actual physical size of it, yes.
The outer
the pitch diameter, yes, we would have.
So we need to check that we're not
Yes.
too close to the outer diameter.
That's correct, yes, but we should have that.
Okay.
Right now, so we need to decide on sizes.
And the diameter.
Yeah, now one of course, with the stress concentration, which is an issue,
Yes.
very large changes in diameter are not so good.
Mm-hmm.
We don't really want to be increasing the size of, or decreasing the size of the shaft as much as, we want to be changing it as little as we can.
Yes.
Okay, so
Okay.
we probably need a
Another
step there
on that.
at the bearing, at the pump end bearing. So aside from the bearings, we just have we have just the two main changes, which is where the pulley and the motor goes, and we've got the step change for each of the bearings. So essentially, you have 5 changes. So 4 changes, 5 different diameters. We would have.
Okay.
Okay. So you can put the information we know. We know that we need diameter of, at the moment, 35 for the motor end bearing. A diameter of 25 at the bearing end, at the pump pulley end, the pump end bearing.
25.
25, yeah. Okay.
Okay.
So what are we going to choose for the other diameters? I suspect change as small as possible.
The step.
Now what we might find in the bearing catalogues is some information about what are the changes in size allowable for the actual sorry, that was wrong. Mouse is a bit oversensitive. What's the minimum shoulder necessary for a bearing? What's the minimum shoulder size it can butt up against?
To locate it, is it?
Yeah, or minimum and maximum, because it will run across, join the two races if we're not careful. The bearing designation was, what did we say the bearing designation was?
For which bearing?
For the
ruler or the
no, for the ball bearings at
okay,
the moment.
think of the ball bearing.
And what I'm going to do actually do is search for something. Product designation
YEL 207
YEL 207
2F, sorry.
2F. Okay. An empty result set.
Maybe
Maybe I was a bit the
using
way it
this.
actually expressed. Contains. Just contains. So
YEL 207 2F.
Empty again. So
Maybe it's the bearing unit definition.
yeah.
SY 35
That's why 35
WF.
WF. Empty again. So this is off. Can we just put something? Just what's it? YEL to see if it returns anything under YEL. Right. What I'm slightly concerned
back
at is
to-
that we're searching within the wrong thing.
Yeah, we are in rolling bearing.
Yeah. What I want to do is I'm going to just go completely out of this. Just go so YEL. So what was it? The bearing
207
207
2F.
2F.
Can we not go back to the original product structure?
So we can have the bearing units is where it came from. Okay.
Bearing.
Primer block units. Okay.
Yeah, product table.
Okay. So product tables, and we chose one with the cast housing and is it
Eccentric
just-
locking
was
collar.
it was eccentric locking collar. It's cast housing.
Oh, sorry, yeah.
Eccentric locking collar cast housing.
Okay.
So
And it
what's
was,
it called? SY35WF. Okay, it's this one.
yeah. And that was the
And the bearing that they should be here.